Alright, we're going to go over multiple transformations of quadratic functions. So, on Friday, you guys looked at quadratic functions where we were just moving the vertex left-right, either moving it left and right and that was the only movement, or up and down, that being the only movement, or compressing and stretching it. Today, what we're going to be doing is putting them all together. So I've put, you can call this like the normal function or a parent function. And what this is putting in all those variables we learned about. We learned about A, and how if A is negative, it flips it. If A is positive, the parabola stays upwards or opening upwards. If A is greater than 1, then we know the parabola gets thinner. And if A is between 0 and 1, we know the parabola gets much wider. We know if h is positive, some number, we're going to actually move the parabola in a negative direction horizontally. If h is a negative term in here, okay, and that's strictly in the brackets, we know we're going to move the parabola horizontally in a positive direction. And we know if k is positive, the parabola moves upwards. And if k is negative, the parabola moves downwards. Okay, so that was a quick recap. We're going to put them all together. So we're going to make up a term here. Y is equal to negative 1/5 x minus 3 squared plus 6. Okay? So, the very first thing I want you guys to do is to pick out each of the terms. Which represents the A variable? What number do we have? Negative 1 over 5. Okay, so this is our A variable. What is our H variable? Negative 3. Good. And then that leaves what to be K? 6. Okay. So let's talk about these individually. If A, first of all, is negative 1/5, yeah, we know the parabola is going to flip. Okay, so it's going to be opening downwards. And is it wider or thinner?
Wider.
Wider. Way to get it on the second try. All right, we know it's going to be wider because the number is between 0 and 1. We know h is negative 1/3, so which direction is it going to go? It's going to go to the right. Okay. Or in a positive direction. And finally, because k is positive 6, what's going to happen to our parabola? Up. Parabola is going to move upwards. Okay. So when we say it's getting wider or moving right or going up, we need a reference point, and that reference point is our normal parabola. That's written like this. Now I can write the normal parabola with these variables in it, and I'll do it in a moment. But first, just make sure we can remember to graph it. Vertex is at 0. From the vertex, we go over 1, up 1. Both ways, it's symmetrical. Then we go back to the vertex, go over 2. 2 squared is 4. Same idea with 3. Squared is 9. Always remember these points. Now, when going to shift it, you can technically do it in any order. You can compress or stretch the parabola, then move it left and right and up and down. Or you can move it up and down, then left and right, and then compress it. Personally, I find it easiest to move the vertex. So in other words, dealing with our h variable and our k variable first, and then applying this. So we're going to do it in that order. And we'll start with k since it's the most intuitive. If k is positive 6, we know the vertex is going up 6, right? 1, 2, 3, 4, 5, 6. So we know that's one of the transformations from the vertex. The next vertex transformation is to the right, 3 units. So from there, we go 1, 2, 3. This is our new vertex. So if you've noticed, we've moved from here all the way up here by going up 6 and to the right 3, kind of like a bingo card. Okay? So we dealt with 2 of them. The last one we need to deal with is our A transformation, which isn't going to be easy. First of all, it's negative. So we know that all of our points are going to be heading downwards. From the vertex, this is why I always told you guys to start at the vertex and go over 1 and square the number. We're at this vertex. If I go over 1, what is 1 squared?
1.
Okay. Now I take that 1 and I need to multiply it by this. What is 1 times negative a fifth? Negative 1/5. So in other words, it's telling us to move over 1 and go, because it's negative, down a fifth. Well, down a fifth is very small in this graph. So in other words, like this. And because it's symmetrical, if I go over 1 that way, I'm going to get the exact same movement with my parabola. Okay? Same idea. Let's go back to the vertex, but this time let's go over 2 units. What is 2 squared? 4. We then got to multiply by our a value. 4 times negative a fifth. Anyone know? 4 over. Yeah. Negative 4 over 5. Okay? So we're going over 2 units. And because it's negative, we go down 4/5, which is almost all the way down one of these squares. So we went over 2, and we'd say this is about 4/5. And it's symmetrical. So we go over 2 again, down 4/5. Let's try 3. Start at the vertex again. We go over 3 units from the vertex. 3 squared is?
9.
Times negative a fifth is what? Negative 9 over 5. Okay? Which is 1 and 4/5. Okay? So what that means is our vertex goes over 3 and we go down 1 and 4/5. So if you notice, this is going to be much wider than what we had before. What I'm going to do is I'm going to take us to a unit where we can get an actual whole number. I'm going to move over 5. Okay? So we're going to skip 4 and we're just going to go to 5 from the vertex. 1, 2, 3, 4, 5. What's 5 squared?
25.
Times negative a fifth. Anyone know?
Negative 25.
Which is?
Negative 5.
Negative 5. Good. I'm glad you guys can do that in your head. Okay, so we went over 5, and then we're going down 5. 1, 2, 3, 4, 5. So this is going to give us a good idea of what our parabola should look like. So I'll get rid of all these arbitrary points that aren't that important right now. These ones in between. Okay, and we're just going to connect the dots. So our new parabola, when we've put it all together, is flipped, wider, and the vertex has moved up and to the right from where it was before. Okay? So that's putting all the transformations together in one movement. Okay? And with that being said, I'm just going to quickly recap. I'm going to show you how this function is normally written, the y equals x squared, with our terms above it. So it should only take a minute. If you guys remember, I said we had, I want this in black. Y is equal to ax minus h squared plus k. So we have our h term, or a term, sorry, h term and k. Okay. Our normal term is y equals x squared. This is what that looks like. Y is equal to x. And these are the values. 1, 0, and 0. Okay? We're going to use distributive properties and all that stuff we learned before to make sure we understand this. First of all, let's talk about the transformations, or the values. Our a value is 1, our h value is 0, and our k value is 0. Well, all that means is our vertex doesn't go anywhere, so we know it starts at the origin, and this is for this function here. And if a is 1, we know that we're going to be able to just apply the normal movements, 1 over, 1 up, 2 over, 4 up, 3 over, 9 up. Okay? The reason this is written like this is because we're going to use our distributive property quickly. Let's deal with what's in the brackets. What is x minus 0?
X minus 0.
It's just x. Squared. Subtract 0, is that going to make a difference?
No.
No. What's 1 times x squared? X squared. Okay? We don't even need the 1. So if you notice, this function here is technically looks like that when we're talking about our a value, our h value, and our k value. But when we distribute everything, it just comes back to however we started. So always remember, our a value is always 1 if nothing's written there, and h and k are 0 if nothing's written there. Okay? Let's look at the whole page.